Okay, good afternoon. So today's lesson is a pre-recording. As you know, I won't be here for your lesson today, and since we missed yesterday's lesson, I don't want to miss two lessons in a row with you guys. Okay, as we know that the grade 11 syllabus is fairly large, so missing a lesson is setting us a day behind already. So as I said, I don't want to miss more than that. Alright, so we're starting the topic on quadratic equations and inequalities. So in grade 10 you learned how to solve linear equations and quadratic equations, okay? You've learned how to solve quadratic equations by factorization. In grade 11 we focus on quadratic equations. We begin by learning how to manipulate the quadratic equation by completing the square. This is the process that we will be doing in this lesson and the first part of tomorrow's lesson. Okay, God willing, inshallah. Completing the square and finding the minimum and maximum values of functions. Then we will be studying methods of solving quadratic equations and inequalities. Okay, you can read again through this. It's on the top of page 24. Now completing the square. Okay. Completing the square, you know from previous grades that the quadratic function, the parabola, has an algebraic form, y is equal to ax squared plus bx plus c. That's your quadratics, okay? That's your trinomial. For example, you got y is equal to a half x squared plus 3x plus 4 and y is equal to 10x squared plus x plus 20. Okay. There are a number of situations in mathematics where you need to write a quadratic expression, which is ax squared plus bx plus c, which is known as a trinomial to you guys, in the form of a open brackets x plus p all squared plus q. This format here we commonly refer to as completing of the square form. Okay, or I use that as completing of the square form. This process is this process is called completing the square. In this chapter, we will use this process in two different situations. Okay. So prior to today's lesson, a couple of days ago, the last time I've seen you, I gave you exercise 2.1. Now this exercise 2.1, it was a simple multiplication. You should have been able to do this at grade 9 level as well. Okay. So that's where we're going to start this lesson today. So at this point, just get the page number there. It's on page 24. Okay. So here we told in this exercise, each of the following are perfect squares of the form x plus a all squared. The question says write each of these perfect squares as a trinomial by multiplying it out. For example, x plus 3 all squared can be written as that, which is that there. X plus 3 times x plus 3, which is going to be x squared plus 6x plus 9. So what we're going to do is, for number 1, you got x plus 1 squared. So just to refresh your memory, what the binomial square looks like, we basically square the first term. Let me just pull this down a bit. Okay. Okay. So what we get is the first term squared, which is x squared. First term, second times 2 is going to be 2x plus the last term squared is 1. Then number 2, we have x plus 2 squared. Can be written as first term squared, which is x squared plus 4x plus 4. Okay, I don't need a bracket there. X squared plus 4x plus 4. For number 3, it's going to be x minus 4 squared, which is x squared minus for x times negative 4 times 2 is negative 8x plus 16. Alright, let's go to number 3. Sorry, number 4. It's going to be x plus 5 squared. It's simply going to give you x squared plus 10x plus 25. Number 5 is going to be x minus 3 squared, which is first term squared is x squared. First term second times 2 is going to be negative 6x plus the last term squared is 9. Remember, the last term is always positive. Okay, so negative squared and positive squared is positive. So you got x minus 8 squared. Square the first term, I get x squared. First times the second times 2 is going to be negative 16x plus 64. Okay? Let's pull this down here. Look at number 7. In number 7 you got x plus 7 all squared. So they give you x squared plus first times second times 2 is 14x plus 49. Look at number 8. It's going to be x plus a squared. That's simply x squared plus 2xa plus a squared. Okay, number 9. Just make sure that I'm not behind the calculator. Number 9 is going to be x plus a half squared. That is simply x squared plus first term times second times 2. It's going to give you x plus last term squared is 40. Okay. Let's pull this down a bit. Okay. And then we are number 10. Okay. Number 10, I'm just going to read it out. It's going to be x squared minus 2 over 3x plus 1 over 9. Number 11 is going to be x squared minus first times second times 2 is going to be x kx plus the last term squared is going to be a quarter k squared. And number 12 is going to be x squared plus x times k over 2 times 2 is going to be xk kx plus k squared over 4. So now they're telling us to look at each of your answers and try and find the relationship between the coefficient of the second and the third term in the trinomial. Now you guys are not here now to tell me if you noticed it or not. If you didn't notice anything yet, at this point, pause the video. Okay? Look at the coefficient of the middle term and the last term. Okay, see if you can find a relationship that exists between those values. Okay. Alright, so now we're back. So at this point, you should have said, okay, the middle term, I must multiply it by a half. You must do it times a half, and that's squared. Now 2 times a half is 1, and 1 squared is 1. Let's look at the next one. 4 times a half is 2, and 2 squared is 4. The next one is negative 8 times a half is negative 4 squared is 16. The next one is 10 times a half, which is 5 squared is 25. The next one is 6 times a half, and that's squared. 6 times negative 6 times a half, negative 3 squared is 9. The next one is negative 16 times a half, which is negative 8 squared is 64. The next one is 14 times a half, and I squared it, I get 49. The next one is 2 times a half, which is 1, and I squared it and I get 1. But remember there's an a, so there's a, so a squared. The next one is 1 times a half, which is a half, and I squared it, I get a quarter. Okay. So that is what we determine is the relationship between these. So in general form, what would that be? If it's in the form of, it's now important to note, if it's in the form of ax, not a, let's for now just say it's going to be x squared plus bx plus c. Okay, to calculate C, the C value, the constant, we're going to say B times a half, and it must be squared. That's how we calculate that C value. So it's B times a half, and it must be B times a half, or divided by 2, squared. Okay. So that is now very important to note, to calculate, or the value to complete the square with. Okay. Now we're looking at the examples on page 25. The examples on page 25. So looking here, they say, what must be added to each of the following to make a perfect square trinomial? So again, we tell ourselves, okay, we got x squared plus 10x plus a number that must be added to complete the square. Alright? So what must be added to complete the square root here? Okay? So we say something must be added in, something must be added in, something must be added. So in the first case, what must be added here? So we say it's b times a half, and it must be squared. What is b in this case? 10. What is 10 times a half? 5. And 5 squared is 25. So 25 must be added to get a perfect square trinomial b. Not so? So, that then can be written as x plus 5 squared. So what I do is I would give you a chance now, you pause the video again and try the next one. Okay, so at this point we're back. So we say, okay, so it's going to be b times a half, and it must be squared. The middle term, coefficient of the middle term, times a half, and it must be squared. So in this case, it's going to be negative 6 times a half, which is negative 3, squared is 9. And again, that's a perfect square trinomial, which now can be written as x minus 3 squared. Let's look at the last one of the examples, number 3. So what must be added to x squared plus x to get the perfect square trinomial? Again, it's b times a half, and it must be squared. What is b in this case? 1. 1 times a half is a half, and a half squared is a quarter. So a quarter must be added to x squared plus x to get a perfect square trinomial. And that, of course, can be written in a binomial square format, which is x plus 1 over 2 squared. Okay. So at this point, again, I would suggest you pause the video and then you do for me exercise 2.5, 2.2 on page 25. Page 2.2 on page 25. You're not going to learn anything if you're just going to watch the video, okay? As you know, mathematics doesn't work like that. You need to practice it on your own. So if we say pause the video, you pause the video and do the instruction. Otherwise, you're not gaining the full potential at this point. Okay, so pause the video at this point. You're only going to do the odd numbers. Okay, so at this point you should have completed all the odd numbers. So let's look at the odd numbers. Number 1, it says find the third term of each of the following to produce a perfect square trinomial, hence factorize each trinomial. So number 1 is going to be x squared plus 8x. So we must add something to complete the trinomial with. Let's look at 3. It's going to be x squared plus 6x plus something, and your perfect square trinomial there. Number 5. It's going to be x squared plus 24x plus a number, which is going to be binomial squared. And number 7 is going to be x. I think this one we just did now in the example as well. Okay. So let's look at these 4 quickly. So the first one is, remember, it's always going to be b times a half, and it must be squared. So what is 8 times a half? 4. And 4 squared is 16. So this is going to be a perfect square trinomial. So this is going to be x plus 4. Instead of writing 16, I could have even written 4 squared. And that is going to be the method I will be applying from here onwards out. Okay. The next one is going to be b times a half. So 6 times a half is 3. And 3 squared is 9. So if I write this as a perfect square trinomial, it will be x plus 3. Remember, the perfect square trinomial takes the sign of the middle term. Let's look at number 5. Number 5 is going to be 24 times a half is 12, and 12 squared is 144. In the binomial square, it will be x plus 12 squared. The next one, it will be b times a half, and b times a half is a half, and a half squared is a quarter. If you wanted to write a quarter, is no problem, but it will be x plus a half squared. The reason why I'm writing it in that format is that you will see whatever is under the root of the square, that is the number that's going in the, okay, not there, but is the number that's going in the bracket as a second term. Okay, and that is the reason why we will be applying it like that for now. Okay, so that was till 7. Let's do number 9. Will be x squared minus 5x plus a number equals to something squared. And number 11 is going to be x squared plus 2ax plus a number, which now can be written as a binomial squared. So number 9 is b times a half, is negative 5 times a half is going to be positive 5 over 2 squared. So it's going to be x minus 5 over 2. Okay. And the last one here, your b value is 2a. 2a times a half is going to be a, and a squared is going to give us x plus a whole squared. Okay. So if you had a problem with this, you're going to redo the odd numbers, and then you can rewatch or rewind the video at this point and remark your work. Okay. Now if you had no problems with that, you then do exercise 2.2 on page 25 as homework for tomorrow. Okay. Or for our next maths lesson. Then in the examples on page 26, they say write each of the following trinomials in the form of x plus p all squared plus q. Now this is a bit different to what the previous question says. So in the previous question we were looking at what once we added to get a perfect square trinomial and factorize the trinomial. Here it's a bit different. We must write it in the form of ax squared plus q. So, looking at the first one, so we say, okay, we got x squared plus 2x. Okay, let's make that in a different color. So we say x squared plus 2x plus 3. Okay, so that's the sum. So we say, okay, what must be added to the sum to complete the square with? Remember, it's going to be b times a half, and it must be squared. And what's b times a half? In this case, 2 times a half, it's going to be 1 squared. Now remember, in mathematics, we don't change the value of anything. Okay? So if we added, say for argument's sake, the answer is 6, and we're adding 1 to the sum, it will not give us 7. But to get it back to 6, I will subtract 1 again. Likewise, if I say the answer is 6 and I add 20, I must subtract 20 again. Likewise, if the sum is x and I add a half, I must subtract half again. Why? So that we can land up with x again. We can land up with 6 again. We can land up with 6. So in mathematics again, we don't change the value of anything. We only simplify. So that's it. if we're going to add 1 to the sum, I must subtract 1 again. Not so? And this is now what we're looking for. That first 3 terms is our perfect square trinomial, which can now be written as x plus 1 squared plus negative 1 plus 3 is 2. Okay. So if you want to write notes, you can write. The first note is you need to find the coefficient of x, which is 2. 2 times a half, and then we square it, we get the third term for the perfect square trinomial. Those notes is on page 26 in the examples. Okay. I'm sure you guys understand from the example itself. Okay. Let's look at number 2. Okay, number 2 says you got x squared minus 8x plus 5. X squared minus 8x plus 5. So again, the question we ask ourselves is, what must be added to x squared minus 8x to get a perfect square trinomial? That same number I add, I must subtract. And I add 5. Okay. This is number 2. So what must be added to x squared minus 8x to get the perfect square trinomial? And I'm sure you guys know the answer by now. It's b times a half, which is negative 8 times a half, which is negative 4, and it must be squared. So negative 4 squared, negative squared will always be positive. Okay? So you'll always see me drop the negative there. So it's going to be squared. And 4 squared is, of course, 16. Okay? So once again, I have my perfect square trinomial there. Alright? So let's write that now in that form. So it will simply be x minus, it will always take the sign of the middle term, as you see in the first example as well. X minus 4 squared. If you had written 16 there, it's no problem. Then it will still be x minus 4 whole squared. What's negative 16 plus 5? Negative 16 plus 5 is negative 11. And that, of course, is in the form of in the form of x plus p whole squared plus q. Okay? Sure you guys understand at this point. And the last one, number 3. You got x squared plus 3x minus 7. Again, the question is, what must be added to x squared plus 3x to complete the square with? Remember, the same number we're adding, we must subtract. And we say minus 7. This value here is that value. That value is 3, that is that value. This was 5, and this is that 5. Okay, you feel like you're a bit confused, that is where those numbers come from. Okay. So again, how do we get the term to complete the square with? It's going to be b times a half. And what is your b value here? Your b value is going to be 3. So it will simply be 3 times a half. Let's make it on the side here. 3 times a half, and it must be squared. Remember, it must be b times a half squared. That's how I generate the third term in the trinomial. 3 times a half is 3 over 2. Squared is 9 over 4. Okay? But here we write 3 over 2 squared. And 3 over 2 squared is 9 over 4. Always note that I simplify this term. I drop the square. Okay? So when I add and subtract, I know exactly it's in that form already. Okay? Again, people, this is now the first 3 terms is your perfect square trinomial. And that is what we wanted. Okay? So we will have x plus 3 over 2, and it must be squared. Then of course we're going to say negative 9 over 4 minus 7 is going to give you 28, is going to be 37 over 4, negative 37 over 4. We don't have to do that in your head. You can say negative 9 over 4 minus 7. Of course, it's going to give you negative 37 over 4. And there's it in the form of x plus p all squared plus q. Okay. So at this point, what I want you guys to do is, again, you're going to pause the video. You're going to pause the video and you're going to answer all the odd numbers of exercise 2.3 on page 27. Right, so at this point we're back. I'm sure you guys had some fun with us here. So let's just run through it quickly. So the first one is going to be x squared plus 4x plus 3, which is going to be x squared plus 4x plus a number to complete the square with minus the same number plus 3. The number in this case is going to be 4 times a half, which is 2 squared, which is 4. Perfect square trinomial. You'll notice that they're going a bit faster because at this point we are just marking the work. Okay? I know most of it's going to be unnecessary because I would have gotten most of it right. But as well, I don't want to just assume that you got it all right, just in case it is an odd one here or there that you made a mistake on. Okay? So it's going to be x plus 2 all squared minus 4 plus 3 is negative 1. Let's look at number 3. Number 3, we got x squared minus 6x minus 2. So again, what must be added to x squared plus minus 6x to get a perfect square trinomial? The number must be subtracted as well. So it's going to be 6 times a half is going to be 3, and 3 squared is 9. Perfect square trinomial. Okay. So that would simply be x minus 3 squared minus 9 minus 2 is negative 11. Let's look at number. Just add there. This is exercise 2.3. Okay, so let's look at number 5. Number 5 is x squared plus 8x minus 11. So again, what must be added to x squared plus 8x to complete the square with? So the number is going to be 8 times a half is 4, and 4 squared is 16. Perfect square trinomial. That will be x plus 4 squared minus 27. Okay, number 7. Number 7 is going to be x squared plus x plus 7. So again, it's x squared plus x plus a number minus the same number plus 7. What's the number in this case? It's going to be 1 times a half, which is a half, and a half squared is a quarter. So that would simply be x. Again, this is your perfect square trinomial. Okay, so that will be x plus a half squared. That's going to give you 28. Minus 1 is 27. Over. Let's look at number 5, 7, 9. It's going to be x squared plus 5x plus 3. Number 11, which is the last one, it's going to be x squared plus 9x minus 1. This lesson is very important, or this exercise is very important for tomorrow's lesson. Okay? Ensure that you understand what's going on here. If you have a problem, you just let me know at the beginning of the next lesson. Okay? So again, a number to complete the square with. So it's going to be 5x squared plus 5x plus the first number minus that number plus 3. So what's going to be in this case? It's going to be 5 times a half is 5 over 2. Squared is going to be 25 over 4. Perfect square trinomial. So it's going to be x plus 5 over 2 squared minus 12 is going to be 13 over 4. And the last one, of course, is going to be x squared plus 9x plus the first number minus the number minus 4. So what must be added here? 9 times a half is 9 over 2. Squared is 81 over 4. So it's going to be perfect square trinomial there. It's going to be x plus 9 over 2 squared minus is 16. 81 and 16 is going to give you 797 over. Alright. Just ensure that the answers is correct here. But as you know, you guys will need to shout out where I'm going wrong. Okay. So this is exercise 2.3. The whole numbers. The first answer, yeah, correct. Number 3, yeah. Number 5, yeah. Number 7, 27 over 4, yes. 25 is 13, and that's going to give you 18. 20, that's 18, 96, 797. Okay, so those answers are correct. Okay, so for homework, I want you guys to do exercise 2.3, the even numbers. Okay, so that's where we'll stop this lesson. Enjoy the rest of your day. Good afternoon.